Welcome back everyone. This is Sachin Kumar, pursuing PhD. I'm a second year PhD student from IIT Kanpur, Department of Material Science and Engineering, working under the supervision of Dr. Kaustubh Kulkarni, and my research topic is diffusion in ternary alloy, nickel-based ternary alloy. Okay. So today lecture is about the previous year gate questions. So whatever we have learned till now, that is heat treatment in the materials. So heat treatment on steel. For steel, there are so many questions yearly they asked in the gate paper. That too, especially in the mechanical paper. Very easy questions, very theoretical questions they will ask. Whatever I have covered in the video lectures, the same questions asked in the gate questions. So we are getting into one by one questions with an explanation. Okay. First question. Ductility of a material with a work hardening. So he is asking that if a material is there, if we are done with a work hardening process, so what will be its ductility? So ductility of a material will decreases when we are done with the work hardening process. This work hardening will changes its microstructural property, which will result in the decreasing in the mechanical ductility of the materials. If it reduces the ductility, there is a increase in hardness. Value. So this is about the first question. The hardness of a steel greatly improves with the hardness will increases with is it by annealing process, cyaniding process, normalizing process, and tempering process. So what will be the answer? Hardness will can be improved with the help of a tempering process. By annealing process, ductility will enhances by reducing its internal stresses or by changing its microstructures, forming a new stress-free grains. By annealing process, the ductility increases. What do you mean by cyaniding process? I have not covered here. It's a surface treatment. It's a surface treatment where the steel are exposed to the atmosphere, nitric atmosphere, and this will result in the deposition of the layer of a cyanide on the surface, and it results in the surface hardening. And whereas normalizing, same, the annealing process is similar to that of the normalizing process. So here also the ductility will increases and reduces its hardness value. So whereas only the tempering process, and if there is a one more option is there, instead of normalizing process, if I has given, instead of cyaniding, if I has given hardening process, hardening, and D, so one more option D, both B and D, if he has given, the correct option is D1, because the hardening process will increases with the help by hardening as well as tempering process, but the maximum hardening can be obtained with the help of a hardening heat treatment process. Okay, this is about the second question. So during heat treatment of a steel, the hardness of a various structure in the increasing order is. So there is a during heat treatment, there is a variation in the microstructures, and this will result in the affects the mechanical properties. So various microstructure that we will get as martensite, fine pearlite, coarse pearlite, and the periodic structures. This martensitic, so for extra knowledge, so how we will get the martensitic? We will get by the tempering process. Fine and coarse perlite, we will get it by the annealing and the normalizing process. Whereas spheroidized heat treatment, spheroidized structure can be obtained with the help of spheroidization heat treatment process by increasing order of the hardness value. So the least hardness is mentioned first, then increasing order of the hardness is the highest at the end. So as we know that martensite is having the most hardened substances, so it should be at the last. So correct option is B and C. So next is, so which one is in between the coarse perlite and the fine perlite and the spheroid? Which one is having the least one? Just we have to find the least one. Second option. So least one is having the periodic structure, because the perlitic structure is having columnar cementite as well as an alpha ferrite. These are having a higher hardness than the compared to the spheroid. So that's why it's having a least one. That means least is spheroid and highest is martensite. Then we will get the good answer is C option. Okay, this is asked in the 2003. In this type of a question, we have to first, whatever we have an basic knowledge, just sort out the options, and remaining you just see the remaining options, which one is preferable. This will save a lot of time. Instead of reading the options, we have to go with the best answers. Okay, from the list given below, choose the most appropriate set of a hard heat treatment process and the corresponding process characters. The process is given, treatment is given, character is given. So here it is only 3 are there. Nowadays it's asked in 2004. Nowadays the so many options are given, like about 4 to 5 they are given, and here to 6 to 7 is given. So tempering process. So what it will do? So we know P, see the P, 3, 4, 4, 1. So then if you go for this one, so austenite is converted to the bayonet, whether it is doing no option. That means P1 is, this is wrong. Okay, austenite is converted into martensite. Yes, this may be the answer, because here in tempering process we will get the final microstructure is martensite structure. So P2. Here tempering will get austenite converted to martensite. We will keep it as an option. So in tempering process, whether cement is converted into globular form, no, this is not a correct answer. So both hardness and the brittleness are reduced. Yes, here it is after hardening treatment. If you do the tempering process, both the brittleness as well as hardness value will reduce. This may be the answer. Okay, so if we see the P 2 4, if it has given 2 4, no, 2 is not given, that means 4. So where is the 4? B and C is having 4, P4. Then we will next go for the next Q1. So austenite tempering, that will help. We have already read, and we will go to for this option. That is because austenite is converted into bayonetic structure. This is the process of final structure of austenite. That is a bayonetic structure. Here it is already given Q1. This is the best option. Don't see the third one, because already it is R2. The martensite tempering will result in the formation of martensitic structure itself. So this is C is the best answer. Next option, the percentage of the carbon in the grey cast iron is given. It's very easy question. So in the grey cast iron, it's about 3 to 4%. So I will write, while you studying, while we giving the exams, just take for the correct answers. While we are practicing, we have to recall from the one question itself. You have to answer 4 more questions like this. So if he is asking these questions, you just take the correct answer. The remaining 3 options, what may be the correct answers, you just write it. It will recall your concept. From 0.25 to 0.75, it's a hypo retractile state. So 1.25 to 1.75, hyper retractile. So 8 to 10%, it's a cast only. Right? But usually we used to, this is not considered, usually we consider 3 to 4% of carbon. See. So this type of questions are given the good example, are given a small example. You have to recall each concept for each questions. When the temperature of the solid metal increases, so what will happen to its property? As we know that if we increases the temperature, there is a reduction in the strength as well as increase in the ductility. So it will move from solid state to nearly, it will go to the liquid state. Its elastic property will increases, hence the strength of the metals will decreases, but the ductility will increases. It will flow smoothly. The main purpose of a spiritization treatment is to improve. So what is the main purpose of this spiritization treatment, and for what type of material it is been applied? This is the two concepts you want to clear. First of all, it is only applied for, we know that it is applied for high carbon steel. So these two options are wrong. Okay. In these two, so which one will be the correct answer? Whether it is increasing the hardenability or machinability. So we know that the hardenability is different heat treatment process. So where we can increase its formation of the martensitic structure, whereas this periodization here martensitic structure, it won't be comes into exist. So this will result in the machinability. This may be the wrong answer and D is the correct answer. It will increase the machinability of the high carbon steel. If a particular Fe carbon alloy contains less than 0.3 carbon percent, then it's called as. It's a common question. It's a very easy question. That is a hyperretractile steel. See, it is already a previous year gate questions. I think it's asked in 2007 or 8. I don't know exactly the. Here in 2004 question paper, if you are solving and you are just revision the things. So he asked directly the questions. See, in this year he is asked the directly question, that is 0.83%. This is a hyperretractile steel. You can save 2 to 2.5 minutes from the each question. This type of question you can invest this time in the other questions where there is a numerical and where is common conceptual questions is there. Here it is, best option is B. The crystal structure of an austenite. This will very easy question. This is B option, FCC structure. Because of this FCC structure, one thing I will tell you. Because of this FCC structure of austenite, it can take about 2.14% of carbon. So you can see from the this is austenite and this is iron carbon diagram, phase diagram. So this is 2.14. From here to here, it is FCC structure. Because of its FCC structure, it can take more amount of carbon inside. It's having more voids to consume more amount of carbon. Whereas for the alpha iron and the delta iron is having BCC structure. And delta iron is also having BCC structure. Because of these two, it consumes very less percentage of carbon. This is a message I want to convey with this simple question. So here we have covered three to four more questions. Okay. So here body centered tetragonal is that this is martensitic structure, and BCC it's about alpha and gamma iron, alpha and delta iron, and it is a gamma iron. These type of questions will be solved like this. An important property of a high silicon cast iron is. So what will be the property? Whether it is hardness, brittleness, plasticity and ductility. As we know this, the cast irons are not ductile in nature. So this is not a good answer. So whether it is, if it is not ductile, whether it is giving any plasticity property? No. And so last option, both are brittleness and the hardness. So we can increase the hardness value. Hardness value is increased. So this is the silicon will increase the hardness value, not a brittleness. There is a difference between hardness and brittleness. It can sustain more amount of load as compared to the material which is more harder are not said to be more brittle, because the hardness is like it can sustain more amount of the compressive load. Whereas for brittleness, if you apply more amount of the load, then it will fracture suddenly. Next question is, here answer, good answer is A option. So white cast iron contains carbon in the form of. So what will be the, it's a memory based question. So what will be the structure of the carbon in the white cast iron? So most of the question, this is very tricky question and very confusing question. Okay. So most of the student they will take as graphite, which is not a correct answer, because the in the, most of the books cast irons, grey cast irons, every cast iron are having the graphitic structures, carbon, whereas white cast iron is having a cementite structure. Okay, so this is a correct answer. So heat treatment process used for the softening of the hardened steel. So this is a hardened steel. After hardening treatment, so what will be the post heat treatment process that will increases it little bit, decreases the hardness value, increases its ductility. This is a very easy question, that is D answer. So this is the most basic questions asked, and it's the most, this is the main application of the tempering process. Material is known as an allotropic or a polytropic if it is has if it has a fixed structure under all the conditions, exists in a several structure form at different temperatures, responds to heat treatment, has its atom distributions in a random pattern. So this is the questions I have explained in the maybe the second video about. So what is the polytropic form? So polytropic form is having same composition but different crystal structures, right? So they are called as polytrophic form. This is the basic definition that we have to remember. So suitable answer for this definition is having several crystal structures for different temperatures. B. A small percent of the boron is added to steel. This will boron usually is present in the as an alloying element in most of the metals and the metals, not only in carbon. In many of the metals, copper, aluminium, the boron is used as an which will enhance its property of hardenability. That means it will shift in carbon. It will shift the TT diagram towards right. Hardenability. The ease which we can form the time to forming the martensite is more by adding the boron inside the carbon. The final question. This is the extra question that I got in the metallurgy paper 2022 recently. The recent question this one when asked about by the critical nucleation. As I explained in the phase transformation video, so we can calculate the critical radius R star for spherical nucleation shape, that is 2 gamma divided by delta GV. So this can be modified as 2 gamma into Tm given as L latent heat into delta T. I think this may be the yes. So substitute all the values are given. So this is the question. During solidification of the pure metal, the radius of a critical nucleation at the undercooling of 10 K into that is given by 10 into 10 to minus 9 meters. Answer with a 1 decimal places. So this is direct question. This is 2 marks question. So given R delta T 10 K and he has given gamma also. So 0.177 joules per meter square and melting temperature is given 1356 Kelvin and second is Tm, right? Latent heat L. So 1.88 into 10 to the power of 9 joules per meter cube. So this is the all the terms he has given. Just substitute. I will substitute and give the answer. Just calculate with the help of a calculators. This is 2.177 into Tm 1356 divided by latent heat is 1.88 into 10 to the power of 9 into delta T is given as 10. So final answer. So final answer is 2.55 into 10 power of minus 7 meters square. So most of the people will do the last mistake here. So he has already given the 10 to the power of minus 9 meter. Okay, we have to convert this one into 10 to the power of minus 9. By taking 2 decimals towards this side, we will get as 255.3. We have to write it as 255.3 into 10 to the power of minus 9 meter. This is the correct answer, not 2.5. Okay, So please read the question properly, answer it accordingly. Okay, so you will get 2 marks very easily within 2 to 2.5 minutes with a correct calculation. This is a recent question in 2002 question he is asked. Okay, this is basic questions that are asked in the heat treatment of a steel. There is a theory questions I have completed, and one question I saw in the about the phase transformations from metallurgy paper, that is a 2022. If I got more questions from both mechanical as well as metallurgy, I will take the one more sessions to solve this question. Okay, in the previous year gates. Thank you.